Alright, now children, we saw next numerical problem, that is problem number 3, and this is also numerical based on root mean square speed or velocity of an ideal gas. Okay, the problem says that what will be the ratio of root mean square speeds? Means you have to find the ratio of the root mean square speed of the molecules of an ideal gas at two different temperature. One is 270 Kelvin and another is 30 Kelvin. K means what? Kelvin. Okay, now you know root mean square speed is directly proportional to square root of absolute temperature. Means at different temperature, a given mass of gas or given gas means ideal gas had different root mean square speed. Now your gas is same. Okay, the gas is same, but due to different temperature, the root mean square speed are what? Different. Okay, so in this particular question, if you see, let's do the solution. So there are two different temperatures which are given. So one temperature 270 Kelvin. So I write this temperature as T1. So 270 Kelvin. Okay, and another temperature I write as 30 Kelvin. That is T2. So I write on T2. So T2 equals to how much? 30 Kelvin. So these are the two different temperature of an ideal gas. Okay, now definitely the root mean square speed of the same gas are different. So for that, let me just consider, let B, okay, BRMS 1, you can do this way also, BRMS 1 and BRMS 2 are the root mean square. I am writing this way, are the root mean square, okay, speeds. These are the root mean square speeds, okay, of an what gas? Ideal gas. Root mean square speed of an ideal gas at what temperature? 270 Kelvin and 30 Kelvin respectively. Okay, 270 Kelvin and 30 Kelvin what? Respectively. Okay, now in order to calculate the ratio, okay, I just write a relation, and the relation, as you know, it is BRMS. The root mean square speed is actually directly proportional to square root of what? Temperature. So BRMS is proportional to square root of what? Temperature. So for one temperature T1, the root mean square speed is BRMS 1. So I write down, therefore BRMS 1 will be directly proportional to square root of T1. When temperature is T, root mean square speed is BRMS. When temperature is T1, root mean square speed is BRMS 1. Okay, so what I do even out here also, I remove the decimal, I remove the proportional sign. If I have to remove proportional sign to equals to sign, you have to put some constant. So this is constant, square root of what? T1. So let me just give this 1. Similarly, for another temperature T2, the root mean square speed is BRMS 2. So I write down BRMS 2 is proportional to what? Square root of what? T2. So even if I remove the proportional sign in this case also, BRMS 2 is equals to what? K square root of what? T2. So let me give this as equation number 2. Now to find the ratio means I divide equation 1 by 2 both sides. As usual, dividing equation 1, okay, by 2 both sides. So children, if I divide equation 1 into both sides, so it will be how much? BRMS 1 by BRMS what? 2 equals to K square root of T1 by K square root of what? T2. So this K and K cancel out. Now the ratio now will be how much? BRMS 1 by BRMS what? 2 equals to, now square root of T1 by square root of T2. So as you know, this can be even written by whole square root of T1 by what? T2. Okay, now let's substitute the value. Now BRMS with 1 by BRMS with 2 equals to square root of T1. Now you know what is square root of T1? And now T1 is how much? 270. And what is T2? 30. So 0, 0 cancel out. Now square root of 270 we cannot calculate, but let me just divide. 3 1s are 3, 3 9s are 27. So it's coming 9 by 1. So this ratio will be 9 by 1. And you know square root of 9 is 3 and square root of 1 is 1 only. So finally, ratio of BRMS1 and BRMS2 is nothing but 3:1. 3 by 1 means what? 3:1. So the ratio is how much? 3:1. So this is the answer for this problem number what? 3. Now we will be solving next numerical problem number 4. Now we solve problem number 4, and this problem is also a problem based on root mean square speed, but in terms of what? Pressure. Okay, because we have already derived the expression of pressure of an ideal gas in terms of root mean square speed. Okay, and from that expression we have done also the root mean square speed can be expressed in terms of what? Pressure. Okay, now question say that oxygen, so one of the gas, okay, we take this gas as ideal gas whose density is given 1.429 kg per meter cube. So let me just write it down. Let me start doing the solution of this question. So we are dealing for which gas? For oxygen gas. Okay, for oxygen gas, your density is given. So, and you know density is marked by letter rho. This is the density 1.429 kg per meter cube. So this is the density of oxygen gas. Now this gas is what? Confined in a container. That means this gas is filled in a container at temperature 0 degrees Celsius. So what is the temperature? 0 degrees Celsius, and 0 degrees Celsius also equals to 273 what? Kelvin. And normal atmospheric pressure. Normal atmospheric pressure means the normal pressure, that means called what? NTP. Okay, pressure, normal pressure. And this normal pressure is basically how much? 760 millimeter mercury, or 76 centimeter mercury, or 0.76 meter of mercury. See, children, remember this part. Pressure can be measured in terms of height, but this pressure can be even written in terms of what? Your unit called Pascal or Newton per meter square. So normal pressure. So what is given out here? Normal pressure. Okay, the normal pressure. Okay, let me mark as P1. Now why I am marking P1? Because we need the question in the question only it said that the temperature of the gas is then increased until the pressure is doubled. So now when the temperature of gas increases, the pressure is also doubled. Neglect any change in the volume of the container. Find the RMS speed of the molecules at this temperature. So you have to find the RMS speed of the molecules at the temperature. Okay, so in order to solve this question, pressure is doubled. That means this pressure, the normal atmospheric pressure, is the initial pressure. So I write on that pressure as P1, and this is how much? 0.76 meter of mercury, because pressure is measured by the device called barometer and can measure in terms of height. But 0.176 meter of mercury, if we convert in Newton per meter square, it is how much? That means 1 atmospheric pressure is equals to approximately 1.01 into 10 power 5 Newton per meter square. So children, remember this part. Normal atmospheric pressure in SI unit is basically 1.01 into 10 power 5 Newton per meter square. Now at this pressure and at this density, when the temperature is 270 Kelvin, okay, we have a RMS speed. We have RMS speed, and you know there is a formula. Since RMS speed means root mean square speed of any gas is expressed by BRMS, and this is given by square root of 3p by rho. So children, this is the expression we have derived already. RMS speed can also written as square root of 3p by rho. P means the pressure, rho means the density. Okay, now if this is the relation which is to measure RMS speed for any pressure, then we have a first pressure P1, the density is known. Okay, so I write down therefore for pressure, let me write down this way, for pressure P1, so RMS speed, RMS means root mean square speed, okay, mean square speed, it is given by BRMS1. Let me write this way only, BRMS1, and that is equals to square root of 3p1 by rho. So I replace p by p1, so that BRMS I replace by BRMS1. Okay, so square root of 3 into p1. What is the value of p1? 1.01 into 10 power what? 5. whole divided by rho. The value of rho is 1.429. Now if you do the calculation, okay, if you do the calculation of this, okay, multiplying this quantity divided by this, and if you calculate the value roughly, okay, you get approximately 460 meter per second. So children, you can do the calculation, multiply this quantity, divide by 1.429, and even take the square root of 10 to the power 5, then you get approximately 460 meter per second. So this is the RMS speed of the oxygen gas at what temperature? 0 degree Celsius, and pressure, that is 1 atmospheric pressure. Now the question says that the temperature of the gas is then increased until the pressure is doubled. Now pressure now has been what? Doubled. Whatever pressure you have, atmospheric pressure, the pressure has been doubled. Neglect any change in the volume of the container. Find the RMS speed of the molecules at this temperature. So now, when the pressure is doubled, okay, your mass and the volume of the gas will not be affected. When the mass and volume will not change, means the density also not change. That means in this question, although the temperature is increasing to make the pressure doubled, but the density, and the density means the mass and volume of the gas is not changing. So let me just write down, since mass and volume have not been what? Have not been affected. Have not been affected means the density remains constant. The density remains constant. Even what? The pressure. Even the pressure is doubled. The pressure is doubled. So initial pressure was P1. Now if it is doubled, means you get a new pressure. So the final pressure, let me write this way only. The final pressure, that is P2, is 2 times of P1. Just double the pressure. So final pressure will be 2 times of what? P2. Okay. So for this question, P2 equals to 2 P1. Now if the pressure is doubled, okay, that means if the pressure changes, the RMS speed also changes, and that RMS speed we need to calculate. Okay. Now, but the density remains same. So as I said, the density remains same. So in this case also we can calculate the RMS speed. So BRMS2. Let me write this way. So BRMS2 is the RMS speed at this double pressure, and this can be written as square root of 3 P2 by what? Rho. See, the formula is same. Instead of P1, I wrote what? P2. Density remains same. Now let me substitute the value. 3 into P1. Now P2 means what? 2 P1 by what? Rho. Okay. Now we can just do this way only. Now 2 I take square root outside. This 2 I'll take out from the square root. It will be square root only. Okay. And it will be inside what? 3P1 by what? Rho. See, I can write these 2 separately. Now the reason why I'm writing, because 3 square root of 3 P1 by rho means this value, this quantity is already calculated 460. Let me substitute. So square root of 2 into 460. This is 460 meter per what? Second. See children, this quantity is 460. So the final answer is the root mean square speed of the same gas, oxygen gas, is 460 root 2 meter per second. This means when the pressure is doubled, okay, keeping the quantity constant, when the temperature even increases to certain extent, when the pressure is doubled, without changing the density of the gas, the RMS speed increases by how many times? Root 2 times the speed that we measure at pressure P1. Okay, so this is a calculation of RMS speed of the molecules of this gas, oxygen gas, at the temperature, at that higher temperature. But when the pressure is what? Doubled. So this is also one of the numerical based on RMS speed. So children, the problem based on RMS speed is very important for your what? Examination also. So we will be doing this much today, and we do continue with other topic from this chapter. Thank you so much.